Hi, I'm David Nolen. This talk, it was still not announced because I didn't really know what I was going to talk about until today, because actually I'm well known in the Clojure world, but whenever I come to JavaScript conferences, I feel like I always need to change things a bit to make it more relevant to a JavaScript audience. But so this talk is going to be, there's going to be a little bit of interesting history from the early days of React, I think a lot of people won't know. I'm not going to assume you know who I am, and it'll help explain why I've been involved with React as a user of it, and why people sort of associate React with myself. But then I'm also going to talk a bit about Clojure Script, and how Clojure Script in many ways is sort of like a parallel universe to the React ecosystem. We don't have that much interest in sort of JavaScript as a big thing, but actually we share a lot of the same principles and sort of philosophy you find in the React world. I'm going to talk, don't get worried, I'm not going to show much Clojure code up until the very end, and even when I do, you don't need to know Clojure to understand what I'm saying. But I hope by seeing what happens in this parallel universe to the React ecosystem, maybe you get some ideas, and maybe decide to give Clojure Script a shot. So I'm a software engineer at a company called Cognitect. Cognitect is a software consultancy. We're the stewards of Clojure and Clojure Script. Clojure is a functional dynamic Lisp that targets the Java virtual machine, and Clojure Script is basically Clojure that compiles to JavaScript. I'm the lead developer of Clojure Script, and Clojure Script works largely because a lot of the techniques that were sort of revolutionized in the JVM hotspot, a lot of those ideas ended up making it into JavaScript virtual machines, which are very sophisticated now. I also work on something called Datomic. Datomic is an immutable relational database. I can't really say that much about it, but if you imagine that you could make a full stack Redux application, Redux all the way into the cloud, I mean, that's the kind of thing that Datomic supports. Check it out. All right, so I've been doing JavaScript since 2005. I remember before jQuery was really a thing. I remember before console log. I remember when JSON parsing was eval. Dark days. Things have come a long way. I worked at the New York Times as a JavaScript Rails developer for about from 2010 to 2014. I was there when Backbone and Underscore were really popular. Jeremy Ashkenas, who created Backbone, Underscore, and CoffeeScript, we were on the same team there. So it was really fun. We worked on some interesting projects. But of course, I was wondering, as somebody who liked Clojure and functional programming, if there was ever going to be something better than traditional object-oriented MVC. So my friend Brandon Bloom did this in December or November of 2013. He was like, check out this thing that Facebook released called React. Like most people, I was extremely skeptical. There were XML literals in a JavaScript file, and I said, this is going to fail. Who wants to use this thing? But as with many great conversations, I had a great conversation over a cup of coffee with Brandon Bloom and Pete Hunt from Facebook. November 2013, React had only been about for whatever, 4 or 5 months. And I had an interesting exchange. So this is, you can see this is from, well, maybe you can see it, but it says December 2nd, 2013. I was interacting with Jordan Valk, who is the original designer and creator of React. And he had said in passing, oh yeah, at Facebook, we had this case where in the comment section of a React app that we were building, we had a performance problem, and we used an identity check because we used persistent data structures. So it was because Jordan Walk had said this that I wanted to drill into Pete Hunt's brain. Do you think immutable data structures can make React faster? And he was like, I don't know. And so I wrote the most popular blog post I've ever written. I had more views on this article than any posts I've ever done combined. And this was the future of JavaScript MVC frameworks, where I basically showed that I could take Clojure Script, which is a compiled to JavaScript programming language. I could take immutable data structures, two things which sound like they should not make anything faster, right? I could combine it with React, and I could be at least 3 times faster than plain React. And I had nice little flame graphs. In fact, you could open up my thing in Chrome and record the flame graph yourself and prove that I'm not making this up. React is faster with immutability. And I showed the typical Backbone application, totally losing out here big. And this helped kickstart, I think, with some people in the JavaScript community to take a second look at React and to start thinking about immutability. 2 weeks after I wrote this post, I showed that without changing anything in my to-do MVC implementation, which was faster with Clojure Script and immutable data structures, I could write 13 lines of code and get full time travel without changing anything else in my program, just because I used immutable data structures and I used single app state. Back in 3 years ago, this is almost 3 years ago, when I talked to people, single app state is the way to do front end, people would just laugh at me. They did not take this seriously. Okay, so now you get a sense, there's a little bit of history you might not have known about my early interactions with the React team. But now let's go through the looking glass and let's see how we see sort of the problem of UI programming through sort of Clojure or Clojure Script glasses. So in Clojure and Clojure Script, immutability is just a language feature. We don't want this to be a separate library. There's a lot of benefits here. You get an ecosystem oriented around immutable data structures, and you can plug these things together and they just work. I think Richard Feldman, when he was talking about Elm, there's a lot of benefits. When you have a language and you have better semantics, and you really have the language sort of enforce the best practices, you actually can build a really powerful ecosystem around these values. So in our viewpoint, once you go immutable, you really can't go back. It just leads towards simpler programs. The other thing that we take really seriously that's actually hard to replicate in JavaScript, though people have tried, you have things like React Hot Loader, but one of the core values in the Clojure and the Clojure Script ecosystem is live coding. So because we always thought you should program around single app state, and then you should program with pure functions, all these things that you hear about, which is great. It's great that this is becoming a mainstream idea, but we knew this for quite some time. If you do this, then doing interactive programming is orders of magnitude simpler to do. So Figwheel is basically anybody that uses Clojure Script uses Figwheel, and Figwheel just works in a way that's completely scales. Whether you're writing Hello World or whether you have an app with its 50,000 lines of Clojure Script, Figwheel just works because all the libraries use the right patterns. Everything is functional. State is not present in multiple places. I just want to give a quick demo of this because it's quite cool. If you've never tried Clojure Script, so here I just have Atom open. Here I have a REPL, and here I have Flappy Bird. So this is not my code. This is just the demo that Bruce Howman made. And here, this REPL that I have at the terminal, this is actually connected directly into Chrome, right? So I can see there's functions there. This is actually talking to Chrome over a WebSocket from a process running on my command line, and then I'm getting feedback. Here, it's printing out. In my source file, I can change this, save it. Boom, I died because I can live edit this. And this is not a toy. This is a toy application, but this is actually how Clojure Script devs. This is how they work. They don't wait. They don't refresh. Right? You don't want to blow away the app state because you want to change a style. You want to change a view. Why should you have to start over just because you want to change one incremental part of your application? So we believe that live programming really helps people be more productive and be more agile as they try to try to solve their problems. Okay, so immutable data structures, interactive program. The other thing we're really serious about is production. So interactive programming, that's awesome, that's cool for dev. But as you know in the JavaScript world, people really want Webpack to work great. People really want Babel to work great. The final build that you're going to send to a client really matters. So we've invested in something called Google Clojure, which sadly, because Google doesn't really advertise it too much, does a lot of the things that people want Webpack to do today. For 5 years, Google Clojure has had dead code elimination, right? Dead code elimination that can actually follow the entire function call graph and say, you loaded a library with 1,000 functions in it, and you used one function. We can eliminate 999 functions and just keep the one that you actually use. So when Clojure Script programmers make a build, the Google Clojure actually eliminates everything down to the functional level, except for the stuff that you actually need. It has also for 5 years had advanced code splitting. And the code splitting is not this sort of like at the module level. People talk about doing code splits at the module level, but Google Clojure can say, okay, you want these things, these different libraries to be in the module, then it will actually look at all your dependencies and say, in these dependencies, you only use a couple functions. We can eliminate those modules and just move the functions that you need to the locations where they belong. Again, this is something that's just been there, sitting there, and I think it will be very hard to replicate, actually, because the way that Google Clojure works, it really requires you to program in a much more static way so that at production time you can get this benefit. It's actually a little bit annoying, but it's the reason Clojure Script programmers don't care is we generate the correct JavaScript for you. It would be tedious, except we do the right thing, and then you benefit from Google Clojure. And then finally, Clojure Script, again, it's parallel to React. There really are no other JavaScript libraries that are in use. There are no other frameworks in use. Because in the Clojure Script world, we don't see React as a library at all, right? For Clojure, Java, it's a platform, right? It gets us into many places where we want to go. We can interact with very sophisticated libraries for the back end. React allows us to do the same thing in the front end, except we can reach all the places where we want to go. If we want to target iOS, if we want to target Android, if we want to target desktop browsers, we now have one thing to target, right? This is why as a general rule, we don't care about faster virtual DOM libraries or what have you. If it doesn't allow us to reach the targets that we want to reach, it really doesn't matter. We have a much more holistic view of why React is valuable. So this is sort of giving a sense. We think about React in quite a different way than I think the typical JavaScript developer does. There are other things that we're interested in, but you hear it, and I feel like this stuff feels like how React felt 3 years ago to me. Whether you're talking about GraphQL or Falcor or Datomic. I'm not going to spend too much time on this, but I think these things absolutely need to be paid attention to. I think there's so much complexity right now between how you build a UI and how you write the back end and how you populate the UI. And I think GraphQL, Falcor have extremely good ideas. I constantly talk about that if you're a JavaScript developer, you should look at these things, you should assess them. I also work on Datomic, and so I'm a bit biased here, but I think Datomic, because of the way it works, is actually also an extremely good fit for doing UI work, because in many ways, it's very similar to GraphQL. You write graph-like queries, and I think it's a really good fit for having to write different kinds of clients. All right, so you think, okay, Clojure Script has made some interesting choices, and actually there's obviously a kind of synergy here, and has this led to huge success? And I would say, no, we've experienced, I would say, moderate amounts of success. I was at Euroclojure in this same venue. The big European Clojure conference was here on Tuesday and Wednesday, and it's about half the size, or a third of the size of this audience. It's a much, much smaller community. But I think the nice thing about the community is that we found a way to be sustainable, and it's because we do care what's happening outside of our little world. This is a slide from Simon Peyton-Jones, who's the sort of lead developer of the Glasgow Haskell compiler. It's the most popular Haskell compiler. And he's talking about, as a language designer, how he's completely befuddled that Haskell somehow avoided this, right? This graph is just as relevant for the typical compile to JavaScript language. Like, I remember there used to be this website called alt.js, and there were like thousands of compiled to JavaScript languages, and all of them probably had one user, the person that created it, right? It really takes a lot more to convince people to use your technology, and a lot of that boils down to you have to really care about what's happening in the wider ecosystem. And you also have to do a good job communicating that you're not anti-anything. We're not anti-JavaScript. In fact, we're only succeeding because of technologies like React and these other interesting ideas that are happening, like GraphQL and Falcor. But we also have, we do set ourselves apart from the JavaScript community. I just told this, there was like fatigue about JavaScript fatigue, right? This is the constant topic these days. But this is a funny slide, right? JavaScript has there's an embarrassment of riches with respect to options. So many options, right? You can, everything is a module, everything is a micro-module, everything is a plugin. I mean, there's these really tiny, there's a sort of emphasis on tiny architecture. At the same time, I think the thing that you need to think about when you see this, and not everything about doing it this way is bad, but I hear people talk about, do all these little things actually fit together? Are you fighting the way that these things fit together? Are these things related in ways that are not actually desirable? And in Clojure, our approach is that we think software is really, it can be too complicated. We want our process to be simpler. We want to use simpler methodologies. That doesn't mean we're giving up on expressiveness, right? We want people to be very expressive, but I think we can do it with less. At the same time, there are some interesting UFO-like bits inside Clojure and Clojure Script, and I'll show one of these really sort of advanced things at the end of the talk, which I think it'll be pretty easy to understand. But at the same time, we have to convince people, right? We have to convince people that we do have a UFO and not a piece of junk in the backyard. So one way to understand, how we think about software, because I can't talk about every aspect of the Clojure philosophy. But my boss is Rich Hickey, the creator of Clojure. I really recommend seeing this talk, Simple Made Easy. It's not actually a Clojure talk. It's just Rich Hickey sort of outlining his philosophy about software. And I think for me, when I saw it, it was really eye-opening, and it sort of reminded me how much I like Clojure and how Clojure really embodies this notion of simplicity and trying to remove accidental complexity from your system. So if you've never watched this talk, highly recommend it. Because simplifying is not about being small, and this is, I think, something that really the JavaScript community could benefit from. Simple has nothing to do with the size of the thing, right? So when I talk about advanced compilation, that I can take a library with 1,000 functions and I have the technology to move one thing into my build. That's simple. Even though it took a very complicated algorithm to make that work, that's simplicity, right? Not that you have little libraries. Nobody cares. This is not what you care about, right? You care about, oh, I want one thing, automate picking out that one thing for me. So thinking about simplicity in a deeper way, I think, is extremely important. Fortunately, I think that this is, some people are beginning to understand what we have to offer. There was a really great talk. I was here on Monday at React Vienna, and was a co-sponsored meetup like React Vienna and React.js and Vienna Clojure. It was really great. I gave a talk on Clojure Spec, and the second talk was really inspiring to me because, I don't expect to convert many of you to Clojure Script. That's really besides the point. It's really just to share some interesting ideas. But it was really exciting to hear somebody talk about how they'd been, like myself, been doing JavaScript since 2005. They'd seen all the various transitions, and they had ended up in a place, they're making a new product, and it's based on Nextjournal. They're making a product, and it was built on Redux and Immutable.js, and they're using Webpack, and they're using Babel, everything that everybody's doing. And he was on stage and saying, I've been doing this for so long, and it's never been as complicated as it is today. And talking about spending a week just trying to get the build working, right? Why? Why am I doing this? Why are these little things that supposedly are modular, they're not really actually delivering on that promise? And it was cool to see that he had tried Elm, which is awesome, and he loved Elm, and he was shocked how much simpler things were in the Elm world. And then, for various reasons, he actually gave Clojure a try, and he was not Clojure Script. He was not a Clojure programmer or a Clojure Script programmer. He just said, let me just see how hard it'll be to transition our application to Clojure Script. And he was like, this is a parallel universe. Oh my God, all the things I learned about Immutable.js, all the things about single app state and dispatching and all this stuff, everybody in Clojure Script already understands it, right? The exact same philosophy. Yeah, the syntax is different, lots of parentheses, but there's no difference on how we think software should be written, no significant difference. And so he transitioned his application, and he's been really excited. It allows him to narrow his attention to actually solving the problem, and that's cool. It's cool to hear that people are seeing what we believe to be true. Okay, so I'm not going to talk any more about that. If you're interested in hearing about more about Clojure Script from the perspective of somebody who really liked JavaScript or likes JavaScript, or actually would like to use Clojure Script and JavaScript together, this is a great talk. Clojure Script for Skeptics by Derek Slager. It's probably one of the most popular talks that's ever been given because it really is trying to explain why Clojure Script if you're already doing JavaScript. It's cool. I recommend it. So again, we're not anti-JavaScript. I mean, people often get this impression. It's just not true. We're actually, I had to change my talk because I've been going to JavaScript conferences since 2012, talking about immutability and Clojure Script and various things. And it was amazing. I'm at this conference and people talk about immutability and they're talking about single app state and all the things that I think are true. But what was amazing to me is this time, literally every code example on the screen is ES6, ECMAScript 2015, 2016, whatever you want to call it. And that really blew me away. And that's, for me, it was a significant change. It's been about a year since I've been at another JavaScript conference. So I realized I should talk about this a bit, because we do actually care about this. And I started a project with Maria Geller, who's pictured here on the left, about a year ago, Google Summer of Code. I knew that we would have to have a story for integrating with CommonJS, AMD, Require.js, all these various module formats, and ES 2016. And I wanted to get the ball rolling. And so Maria Geller, we worked over summer to get basically an alpha quality thing. Juho has continued this work. Juho Tapiri, he's viewed here on the right. And so we actually do take integration very seriously. I saw a talk on Tuesday where it was a person talking about how they had a Rails backend and they wanted to do Clojure Script on the front end. And the truth is that The back-end people are doing front-end work, and they also have front-end work people doing stuff, but they have designers. And designers know CSS, and they know JavaScript, and to be honest, there's so much literature on React now. And a designer can easily, spend a couple days on React, write some stateless components, some functional components. They're able to do this. And so, I heard from them, and this was a validation that we're on the right track here, is we want people to be able to write, to integrate ES6 and JSX. And so this is alpha quality thing, so I'm demoing it, but it works, but we would like this to improve. And if you're excited about this, we're all definitely looking for help. But here is an ES6 file. This is some React component as a class. We export it. And here I have some Clojure code. And here at the top you can see I can just load it, right? The compiler will actually compile all these things together and create one build. And actually the cool thing about this is that dead code elimination and all that stuff, that will work on this file. This will get compiled into something that supports advanced compilation. So there's other benefits here as well. So we are very serious about JavaScript interop that follows modern best practices. Okay, so enough about that. So now I want to end with a little bit of a spaceship thing. So this is it's cool to talk about. Hopefully you get some sense of why Clojure Script is cool and why we love React and the React ecosystem. But here I want to talk about a spaceship thing. So at Cognitect, we actually think there's a lot more mileage to dynamic programming languages, even though we think there's nothing wrong with typing or any of these projects, whether it's Elm, Reason, Flow. The truth is, people like these languages because the types give you a type of software specification, right? The reason people like types is you document what the thing does, what it returns, and then when I sit down to write your program, I can look at the types. The types help me understand the meaning of the program. This is extremely important. The hardest part about software is like, what the hell does any of this stuff do, right? So anything that helps us understand this is a good thing. So doc strings, documentation, and types, right? You want all this stuff. So Spec comes to this problem with a slightly different hat, right? It says, yes, we want to do this type of specification, but wouldn't it be awesome if your specification did way more? For example, if it could generate example data, right? If you could actually use your specification to create examples, or if you could use your specification to automatically test that the software is correct without writing the test, because the spec tells us how to test the function. And that's really powerful. So I'm going to demo this. All right, so, whoops, that slide. Here we go. So here is, I did a spec talk, and it's going to be a little bit different. This spec talk is going to be much more oriented around, I think, a UI audience. So here, imagine I want to specify my app state, right? So one thing I like about JavaScript, and I think where JavaScript and Clojure Script are very aligned, is when I fell in love with JavaScript, what I liked about it was like, I can write some objects, I can write some arrays, I got some strings, I got some numbers. It's just some generic information, right? Even if you do type stuff, right? When you do a typed program, you still often have to communicate between parts of your system through generic information, JSON, some generic interchange format, which doesn't actually have that much information about the semantics of what actually is going to happen at each endpoint. So the truth is that most systems are like this. Most systems have to exchange generic information, not very type-specific information. In Clojure, we like this simple approach. Just program with generic data. Now the problem with, as everybody knows, right, with JSON, is that when you get a huge payload from the server, what is in there, right? The only way you can know is to read the docs, and the docs might not be true. There's no way to know what's in the structure of the thing, right? And as far as I can tell, people have done like JSON schema and whatever and what have you, but they only want to work on one part of the problem, right? So they're only talking about specking the wire. But we believe that we actually want this capability all throughout our program. It doesn't matter what you're doing. Whether you're writing your program, whether you're talking to a remote service, you want to be able to talk about specification in an expressive way. So imagine I'm building an app state. So here, there's going to be a task. There's going to be a task. And we're going to have a property in there called completed. So I'm going to do MVC just to keep this simple. A task will also have a title. Ignore this for now, though this part will make sense here in a second. What is a task? A task is simply a map, or an object, you would say in JavaScript, with a title property and a completed property. That's all that it is. And the completed better be a Boolean, and title better be a string. And then here I can ask the question, check this map, this untyped map. There's no type, right? It's just a map or just an object. Is this a valid task? And this should return false because 1 is not true or false, right? This does not satisfy the specification. Here, we should get true because completed respects the spec. And then what's really cool is that we want to know why the spec failed. So when I get something from the server and something went wrong and something is not in the right place, you have to dive into it and spend hours just figuring out where did we go wrong inside of the structure of the thing. Spec is completely fully recursive and it will give you the path into the failure. So here I can say, explain to me why this doesn't work, and it says this value 1, the value 1 inside of this map doesn't satisfy the completed predicate because it's not a Boolean. This is exactly what you want to see. And this actually can be given out to you as data, and we hope that people will take this capability, which is runtime capability to explain errors, and do Elm-like error reporting, which would be really, really awesome. So it doesn't matter how big your response is or your data structure is, you would get a precise location and say, right here is where you did the wrong thing. You got a number and you expected a date. Okay, so the way that spec works is it's basically based on the theory of regular expressions. As programmers, you probably think, regular expressions, that means strings. And we say no. We know that the theory of regular expressions is super powerful. All you have to do is add recursion, and basically you get the same power as context-free grammars. Right? That's what you get if you add recursion to the theory of regular expressions. So here we can say, let's support the idea of star, same way you would have, say, star for matching in a regular expression. Here I say to-dos. A to-dos list is just a sequence of tasks. Okay. Then here I say, is this valid? Here. Is this a valid sequence of to-dos? There's a string in here. Right? Doesn't make any sense. And we'll say, no. Explain why this isn't right. Again, bar fails the specification. It's not a map, right? Here, if I fix this, of course, that will work. Now where it gets really cool is you spent all this time. Like, this is the thing I don't like about typing. If you do all this typing and you're actually typing to get the types there, you want to know that you're getting a lot of mileage out of this work that you have to do. And in spec, we think it's really important that this is the case. Here I can say, now that I've specified the specification, generate some examples. Give me some examples of what this should look like. And so here you see that it's able to produce on the fly something that matches that spec. Imagine if all the functions that you had, right, that people are writing, imagine they all had specs, and instead of being like, what the hell am I supposed to build to get this thing to fucking run, you can just make it. We can make it for you. So here's filter. So imagine we want to spec the entire app state. So the app state will have filter and it'll have app state in there. So the single atom will be the active filter and the to-dos list. And here I can go, show me this. Let's do this again because that's a bit empty. So this is an app state. So I could just feed this into a React binding for a Clojure script, right? There's the filter and there's a list of to-dos. And that's pretty sweet. I'm going to show one thing, and this is not something you should do. I'm just showing this because I want to give a nice, simple example that you can understand. So what I want to do in this app state, I want valid app states to be only the case where the filter matches the contents of to-dos. So if the filter says active, there better not be any to-dos that are completed. If the filter says completed, there better not be any in there that are not completed. Of course, this is not something you want to do in a real list application, but the truth is, in your app states, you have cases where you have invariants where some state is here, and then there's other state that better be this way. There's an invariant that should be maintained. And I guarantee most of the people that are doing this, if you're doing this in your programs, you do this in an extremely ad hoc way. And so spec gives you a disciplined way to do this. So here I'm going to say valid app state, and I'm going to say the only valid app states are ones where if the app state is completed, there better only be completed things. If it's active, there's only not completed things. And the only case that it's not one of those two is if the filter is all. No other states are valid. So down here, I'm going to make a dummy app state, which is invalid, because here it says completed false, right? and it's in here, so this can't be valid. So I'm going to evaluate that. I'm going to say, check it, and it says no. If I switch this to true, boom, it works. All right. So let's see the a less trivial example, and then I will be done. Okay. So I'm going to write a function. It's going to take an app state, and it's going to produce a new app state. What does this function do? It takes an app state. The function is called apply filter. It takes an app state. It applies the filter, and the thing that comes out the other side of it better be right. So I've written a function which has a bug here. I've written a function that has a bug, and I'm not going to write any tests because I wrote a spec, and because we can generate data. I can get Clojure Spec to show me the smallest app state that proves this function is broken. So here I can go check, apply filter, and we can scroll back up. And here it says, right here, this is the smallest argument that it could find. So it's not just a gigantic app state. It's the smallest app state that I can find that doesn't satisfy the thing. So let's just copy and paste this. Drop it down here. And let's apply it. And we know this is wrong because the filter is active and this is completed, right? That's not right. So this is awesome. When you're doing testing and something goes wrong, what do? The next 8 hours of your life is finding minimal cases. The smallest thing that causes your program to break. And I've shown you that we can determine this for you automatically. So hopefully you're some interest. There's nothing about this that's specific to Clojure, right? This is an idea if you're inspired, you could walk home today and make this for JavaScript. I think this is a very powerful way to talk about programs and describe programs. So that's all I had. So thank you very much.
Well, amazing. Thank you. Let's have a look at the questions.
Okay. So the first question: what level expectation do you need? Actually, OhmNext is actually designed after doing this stuff for about 10 years. So I don't actually recommend it that much if you're just getting started out. There's a framework called Reagent, which is very much like Redux. So if you're familiar and you're comfortable with Redux and you don't really want any more help than that, or maybe you're not convinced that Relay or Falcor is a good idea yet, OhmNext, which is really what we're working on now, really assumes that you understand why Relay and Falcor are a good idea. And that's actually a lot to understand. So I would say if you just want to play around with Clojure Script and you want to have fun, don't look at Ohm. Try Reagent. It's very easy. It's very simple to get into. Tons of examples. Great community. So should I start with Clojure Script or Elm? Why? I mean, I think Richard gave a great talk about Elm yesterday. I think you should try both. I mean, they're both fun. I mean, what I'm trying to convince you to do is just to try it, and maybe you decide you want to use it, but even better would be if you got some ideas. I mean, my talk was about how I constantly come back to the JavaScript community to get ideas, and I think we can all do better collectively if we're trading ideas. So I think you should try them all. Okay. The autocompletes last year, what? I'm not going to answer that one. Okay, what do you think about Reason? I actually haven't had time to look at Reason. Sadly, I missed most of the talks because I'm working on this one. So I will have to look at Reason, but I did get to talk to some people working on Reason, and Reason sounds cool. I mean, Jordan is obviously a very smart guy. He created React. I mean, if he's working on something, I'm paying attention. What's the easiest way to start with Clojure Script? So Figwheel. It's you can go, if you use OS 10, brew install, line, Figwheel new, or whatever, and boom, you have a Figwheel project. I see Spec as an opt-in way to get static type-ish benefits. I hope that I explained why this is not like a static type system, so I'm not going to answer that one. Is that it? Okay, cool. Thank you.
Awesome. Thank you very much.